This video talks about the first milestone and these noise sources. So you can see here that we have these three noise sources model the fluorescent light. So this is the DC level, this is a low frequency noise, this is a high frequency noise, and then this is our signal. Right now I'm just running it through a resistor, and if we run this and look at the voltage here, first of all, you see that there's this large oscillation here. This oscillation right here is this 60 hertz signal. The DC level means that it's centered up at 1 volt, so that's caused by this DC part. We have this oscillation right here that's going up and down. That's our actual signal right there. And then our noise is this peak to peak, this high frequency noise going back and forth there. So we want to look at what the specs are. So what we want to do is we want to measure the voltage signal and then the noise signal. So first of all, for the voltage signal, we're going to come in here and we're basically going to turn this off by just making it 1 picoamp and leave this one at the 40 nanoamps. If we run this, you see we really just have our signal. And then if we look right here, we're just looking at what is the peak to peak of the V of our out, and you see that that's basically 8 times 10 to the minus 5, or 80 microvolts peak to peak, which is our Vs. So if we come in here, we're going to write that down as Vs equals 80 e to the minus 6. Now we're going to go in and we're going to measure the noise. So we're going to turn these back on. So these were at 400 nanoamps. And we're going to turn our signal off. So we're going to make this one the 1 pico. We're going to run that. And you see it has this DC noise. It has this high frequency noise. We're grabbing the peak to peak. And you see it has a peak to peak of 1.6 millivolts. So if I go in, and that is called the Vn. And so the goal here is we need that this Vs minus this Vn needs to be greater than 200 millivolts. Obviously here our noise is actually bigger than our signal, so we're going to have to first of all amplify it, and then we're also going to have to filter it. The last spec is that we need to make sure that these current sources, which model the diodes, have to remain reverse biased. So the voltage at this point, which is labeled DC, has to be higher than our output voltage, which is right here. And that's kind of labeled right here. We're just looking for the minimum. So right now, that has a minimum of 2.7 volts. That has to be greater than 0.5, so this is fine. But you see, if we were to come in here and put in 100K and run that, you see the voltage at this point is now centered at 100 volts. This voltage here is right around 3.3. So you see now this is negative 96 volts. Well, that's definitely less than the 0.5, so you would have missed that specification. And that's how these work.